So we will work out the second example of bode plot. Transfer function given as g of s into h of s is equal to 10 into s plus 5 s plus 50 by s into s plus 20. We need to convert this one into time constant form. That is equal to 1 plus s to form. So g of s into h of s is equal to 10 into 5 into 50 s by 5 plus 1 s by 50 plus 1 by s into 20 s by 20 plus 1. After simplifying this quantity, you get as 125 s by 5 plus 1 s by 50 plus 1 by s into s by 20 plus 1. So the advantage of converting into time constant form is we can directly have the corner frequencies. Here the first corner frequency existing at omega is equal to 5, and second one is at omega is equal to 20, and third one is at omega is equal to 50. So the next step is we need to calculate the initial slope. Since one pole is existing at the origin, initial slope will be minus 20 dB per decade because one pole at origin, and the initial magnitude will be plus 20 dB, opposite to this initial slope, opposite sign to the initial slope. Initial slope is minus 20 dB per decade, then initial magnitude will be at plus 20 dB. It is varied at when assumed frequency is 0.1 radian per second. So initial magnitude will be 20 log 1 by 0.1, that is equal to, we have to substitute 0.1 in place of poles or zeros at origin. So you get the initial magnitude, you get as 20 dB. This is varied for k is equal to 1, but here our k value is 125. So the modified magnitude will be 20 dB plus 20 log 125, you get as 61.9, and it is approximated to 62 dB. So the magnitude will be 62 dB. See, initial magnitude 20 dB, and the slope will be minus 20 dB per decade. This is, it always cut the 0 dB axis. We assume it is a 0 dB axis. At omega is equal to 1, and here k is equal to 1. But our magnitude is 62 dB per k is equal to 125. Okay, so the slope is not going to be changed in the same slope. Next we denote the corner frequencies, and omega is equal to 5 radians per second, and next is 20, and next is 50. Okay, when it reaches to the 5 radians per second, Here at omega is equal to 5, one pole, one zero is added. So slope will be plus 20 dB added. So the resultant slope will be 0 dB. At omega is equal to 20, again one pole is added. Here one pole added. Okay. So we need to find out the magnitude at omega is equal to 5 now. Okay, for this we have a formula, that is slope is equal to difference in magnitude by logarithm differences of frequencies. So with this we can have magnitude at 5 as 28 dB, and this is 28 dB. Okay, the same 28 dB is carried out at 120 at omega is equal to 20 dB, because the slope is not going to be changed, then the magnitude is same. Okay, then when at omega is equal to 50, at omega is equal to 20, one pole is added, so the resultant slope will be minus 20 dB. It is 0 dB. When it reaches to the omega is equal to 50, one zero is added, again the slope becomes 0 dB. Okay, so we need to find out the magnitude at 50 now. That is equal to slope is equal to difference in magnitudes by logarithm differences of frequencies. You get as magnitude at 50 is equal to 20 dB. It is the same as the initial magnitude. Okay, so this is the simple bode plot. So we can find the k value in other words also. K is equal to 125. What is omega value? We can find. We simply extend the initial slope line to this one. Here it cuts the omega is equal 0 dB axis. This is 0 dB axis. So the same formula applied to find the omega value for k is equal to 125. That is equal to minus 20 is equal to magnitude difference 62 minus 0 log of 0.1 minus log of omega. You get omega as 125. So k is equal to omega at 0 dB. Number of zeros are poles. If it is 0, it is replaced with number of zeros to minus sign. If it is pole, number of zeros, number of poles with the plus sign. So here number of poles are 1 and here number of poles are 1 at the origin, so it is plus sign. It is another way to find out the k value. Okay, thank you.